Good morning, everybody. It's 9:30. We will start the second session of the webinar on how to complete Mss Composer for pesticide metabolism studies. I hope you have enough time since Monday to relax and also to try to complete the composer and open it in Metapath. So today we will start with Vincent and the livestock composer. We will enjoy a coffee break and then William will present to you the rotational crop composer. We will follow the same structure as on Monday with a theory part, a live session, a short video to summarize key points of the session, and a Q&A session. I'd like to remind you that the webinar will be recorded and that the question can be submitted in English in the Q&A box. So now I will give the floor to Vincent, who will present the livestock composer.
Thank you, Gail. Good morning, everyone. I hope everybody is fine. I will share you my screen. And so for this morning, to begin this morning, we will talk about livestock metabolism study, and we will see how to fill in MSS livestock composer. As performed for plant MSS composer on Monday, we will go through all sections of the MSS composer, so general info section, material and method, results and discussion, conclusion and appendices. This presentation about livestock MSS composer will take approximately 1 hour. But before going on the presentation, I would like to precise something. In all the presentation I will give you, I will detail some filling instructions of MSS composer and the nomenclature to respect. This is very important because these filling instructions and the nomenclature proposed have been created to allow a good display in the Metapath database. So it's really important to respect these instructions and the nomenclature proposed. So first of all, we have to open livestock MSS composer. So on your computer, once the MSS composer has been installed, you have to select livestock MSS composer icon and you have to click on it to open the MSS. A startup window will appear. The three MSS composer, livestock, primary for plant primary crop and for rotational crop, share the same architecture and the same functions. It is exactly the same manner to fill in MSS composer with data from a metabolism study. So in the next slides, we will particularly focus on specificities of livestock MSS composer. In the upper part of the window, we find icons previously detailed Monday for plant MSS composer. You have the new icon to create a new XML file. You have an open icon to open existing XML file. You have a save icon to save file or to save file as, and you have also the render icon to convert XML file into a Word document. In the upper part of the window, different functions are also available to copy, paste, and to modify text format. As performed for plant MSS composer, we will go through all sections of the MSS, so general info section, material and method, results and discussion, conclusion, and appendices. But be careful, for livestock MSS composer, you must encode the study in the right tab of the MSS composer. That is to say, poultry, lactating ruminant, or other animals, depending on the animals dosed in the metabolism study. Take care also to save your file regularly because MSS XML files are not automatically saved when quitting the program. And be careful also with decimals number. You have to use the point and not the comma. And last warning for this slide, if you encounter an anomaly while coding an MSS Composer, the anomaly will be passed on to other MSS XML files if these are opened at the same time. After explaining the opening of MSS Composer, let's talk about the general info section of the software. As previously detailed in Plant MSS Composer, to begin data inserting, click on poultry, lactating ruminants, or other animals, depending on the animals dosed in the study. After this, you have to click on one general info sheet. Then click on the Add button below References. Clicking on Add button will activate those fields which define the citation. This reference field should be filled in with the study report number. After adding reference, different cells are now available to be completed regarding study reports. So the authors of the study report, the date of the study, number of pages, study title, reference type, testing laboratory, and the last is company study number. So proceed by filling in pertinent information by mouse clicking within the boxed areas designated for those parameters. You can directly type information in this field, but you can also copy and paste information in these boxes. As for Plant MSS Composer, by clicking on the Edit button of Identifiers in the right part of the window, you will be able to update, to add, or to delete some identifiers. And to end with the General Info section, some fields must be filled in, such as test materials, guidelines, GLP for good laboratory practice, acceptability or not of the study, executive summary, etc., etc. Those fields has been previously detailed on Monday for Plant MSS Composer, so that's why I won't explain one more time this field for Livestock MSS Composer. It must be noted that contrary to Plant MSS Composer, product type and product use boxes are not detailed in Livestock MSS Composer. In the next slides, I will present you the material and method section of the Livestock MSS Composer. In comparison to plant and rotational crops MSS Composer, it is exactly the same manner to fill in materials and method sections. In Part A, materials, there are two parts, one for test materials and the other for animals. Populate fields under one, test materials, by directly typing information. The first tab summarizes general information about the active substance. So fill in this table with common name, gas chemical name, molecular formula, etc., etc. For most of these cells, do not exceed 250 characters. For radio-labeled test materials, you have to click on the Add button. This will activate the fields for data entry. A first radio label will appear in the white box below the Add Delete buttons. Right-click on the radio-labeled one to rename the radio-labeled molecule following this nomenclature, radio-labeled group and common name. Next, fill in the radiochemical purity and specific activities, if available, in the metabolism study report. To add the two-dimensional structure, you have to click on the pen drawing icon to the lower right of the structure box. A 2D editor opens as a drawing package to build the structure. Alternatively, a smile code can be introduced by pasting in the smile field and validate structure by clicking on the OK button. Then we continue with the population of the physicochemical properties tables. The physicochemical properties tables contains pre-populated rows to assist you in population. Actually, all tables in the composer are pre-populated with titles, format, and column headers to make their population easier. However, there is some flexibility to change column headers and rows. A right click allows the user to delete rows, clear rows, copy rows, insert rows, or clear an entire table. And parameters may also be amended by simply typing in the box parameter. Column headers may be amended by right-click invoking a pop-up box that allows the user to change the text. Next, in the section of materials, the general test animal information tab have to be filled in. So in this tab, you have to specify species. For this parameter, only use common name of the livestock species. After, you have also to precise the breed. You have also to precise the age and the weight at study initiation of the livestock with the value and its unit. You have also a box where you can describe the health status of the animals during the metabolism study. And to end with this table, you can describe the housing holding area of livestock during the metabolism studies. Most of these boxes are free text field with limited number of characters, except for age and weight boxes filled in with a value. Age box must start with a figure, and figures need to be separated from the unit by a space. And only figures and columns entered in weight box are taken into consideration in Metapath database. So be careful about these two warnings for these two boxes. Next, move to B, study design under section materials and methods. First, a value must be entered in number of animals tested per dose group. Then a free text field for rationale for selection of dose group and analysis of feed and water are presented. Then you have to complete test animal dietary regime table. Here below the filling instruction to do this task. You have to enter a limited number of characters for composition of the diet and in water columns. You have to enter value and its unit for feed consumption and the acclimatation period. You have to select yes or no for predosing column to know if a predosing occurs in the metabolism study. And take care, because for the acclimatation period column, this column must start with a figure. Figures need to be separated from the unit by a space character. And when you encode a range, hyphens have to be bounded by space characters. So be careful about the acclimatation period box and the filling instruction for this parameter. The second tab of Part B study design is relative to test animal dosing regime. Treatment type column is pre-filled by the software, but you can change it if necessary. If several lines have to be created, respect the following nomenclature: abbreviation of the radiolabel test material, underscore a role. In the treatment level box, fill in with the theoretical dose administered to animals in the metabolism study. Do not forget to specify the unit, and if different treatment levels are tested in the study, create a line for each treatment level. In the vehicle column, this column is pre-filled by the software. For instance, it's capsule, feed bolus, or etc. And you have to select or to write down the correct information for this vehicle parameter. Parameters column is also pre-filled, but you can modify it if needed. Experimental dose administered to animals have also to be detailed in the dosage rate columns. Do not forget to specify the unit. And if the administered dose is not the same between the radio-labeled test materials of the study, create a line for each radio label. To end with this table, you have also to specify the value for timing and duration of the administration in the study, and also the one for timing from final dose to sacrifice of livestock. The next table in Part B study design deals with sampling information collection. Number of sampling per day for eggs or milk, depending on the livestock tested in the metabolism study, is detailed in the first column. Then data about number of eggs or amount of milk produced during normal production is collected in the second column. For feces, urine, and excreta, number of sampling per day is also detailed. In the interval from last dose to sacrifice box, please enter the value and its unit. And in the last column of this table, tissues harvested and analyzed in livestock metabolism study are detailed. In the last part of the study design section, and as for plant Mss Composer, different information about sampling can be detailed. First, you can attach and then clear or view a flowchart of the extraction and fractionation, First, so you can attach and then clear or view a flowchart of the extraction and fractionation schemes. Then a free text field allows you to briefly describe the methods of extraction and analysis. If needed, files or diagrams can be attached. A second free text field allows you to briefly describe the methods for identification and characterizations of compounds. So, after this short presentation about opening general information and material and method of livestock Mss Composer, I would like to do a live session about these three parts and to show you how to fill in Mss Composer for general info section and material method. So I just close my presentation and I would like to do a live example. So you can see that on my computer, I already installed and downloaded the 3 Mss Composer. So I have to click on Mss Livestock Composer to open it. And a startup window will appear. As described on Monday for plant metabolism study, we have different tools and icons to open a new XML file, to create, a new XML file, to open an existing XML file, to save XML file, and to convert the XML file into a Word document. And what is important to have in mind for this livestock Mss Composer is that there's one sheet for each livestock species. So one for poultry, if you would like to encode a poultry metabolism study, one sheet for lactating ruminant, if you want to encode a metabolism study on lactating ruminant, and another sheet relative to other animals, depending on the animals dosed in the study. So for this live example, we will focus on the poultry sheet because I will open an already pre-filled Mss Composer because I don't have the time to enter all the information for this Mss Composer. So some fields are already pre-filled, and in this live session we will also enter some information which will be more specific to livestock Mss Composer. So we can see that there's also a citation already created for the poultry sheet. Different information about the metabolism study are already detailed. For example, name of the authors, the date of the study report, the number of pages, and the study title. So here we will work on a study named The Metabolism of 14C MTP WB 2931. So the name of our fictive active substance for this example in the laying hen. We have also the reference type, the testing laboratory, and the company study number. In the general information, we must add the information about the name of the active substance in the test material name, the guidelines followed in the metabolism study. There's also some information about if the good laboratory practice has been followed or not. So, for example, here the GLP was followed, and you can select yes or no depending on the study. You have also a field to precise if the study is scientifically or not acceptable, and you have also the last field of this general information about this general info section is relative to evaluator's name, so the person who created the Mss Composer or the person who validated the Mss Composer, and you can also precise its affiliation or his affiliation. You have two free field text for background information to insert data about the active substance, for instance, and you have also a box to add the executive summary of the study report. And you can see that the summary has been already entered in this box. Before going on materials and method, just to finish on the general info section, do not forget that if you want, you can edit identifiers by clicking on the edit button. You can add or modify different identifiers thanks to this function. Well, for now, I would like to go on materials and method sections. So for this section, we have two parts, one about materials and the other about study design. So in the first tab about materials, you have a first table to summarize information about the active substance. For example, its common name, its gas chemical name, its molecular formula, etc., etc. One important box and field in the materials part is relative to radiolabeled test material, where you can precise all radiolabel tested in the metabolism study. So, for example, here there are two radiolabel tested in the metabolism study, one radiolabel on the cyano group and the other radiolabel on the pyrazole carbonyl group. If you want, you can also delete. You can also add another radio label if there's a third radio label tested in the metabolism study. Do not forget to specify the radiochemical purity, the specific activities of the radiolabeled compound, and do not forget also, which is really important, to add the structure of the radiolabeled compound. So for this, you have to click on the pen icon here. The 2D editor opens. You can directly copy and then paste smile code in this field to create the structure, or you can also directly describe and draw the structure according to the drawing functions of this 2D editor. Okay, and after radio label test materials, there's also a table to recap physico-chemical properties. So this table is already pre-filled with some physico-chemical parameters, melting point, pH, density, etc., etc. So if you want, you can add some lines if you want to add some physico-chemical parameters, and you can precise some notes, some remarks about those parameters. Do not forget to specify the value for each parameter and the units. And you can also precise the reference of the physico-chemical parameters. In the part A materials, I would like to do a focus and a live filling in of the table detailed in part 2, animals, and this table is named General Test Animal Information. This table is specific of the livestock Mss Composer. That's why I would like to fill in a live session. In this table, first, you have to specify the species tested in the livestock metabolism study. So here, it was N. After this, you can also precise the breed. So the breed was Raren in the metabolism study. You can add the age of the N dosed in the study. So the N were 25 weeks old at dosing. You can also precise the weight at study initiation. So here the N's weighted between 1.6 and 2 kilogram. Do not forget to precise the unit in just after the value or in the title column. If you want, you can also precise the health status of the ants during the study. So here it was satisfactory according to the study report. And to end with this table, you can precise the description of housing holding area. So the ants were individually dosed in metabolism. So in metabolism kgs, the temperature was around 20 degrees Celsius. The humidity was between 33 and 88%. So you can add those kind of information in this last column of this table. So let's move on to B study design, which is more specific to the livestock Mss Composer. So first, you have to precise the number of animals tested per dose group. So here it's 5. You can precise the rationale for the selection of dose group. You can directly type information or copy paste. So in the metabolism study encoded, this information was the laying hen was chosen as a typical poultry species used for egg production. And for the analysis of feed and water, this was that the food consumption was measured and recorded daily during acclimatation and study periods. Periodic analysis of the mains water supply is undertaken. After precising this information, you can detail some other data in the table test animal dietary regime. You can precise the composition of the diet. Here it was layer pellets. You have to precise the feed consumption. So, for example, the hens ate approximately 129 and 213 grams of diet per day for all the 10 hens. You can precise that the water was tap water ab lithium. You also have to precise the acclimatation period, which was 14 days in the metabolism study. And do not forget to precise if there was a pre-dosing in the metabolism study. There's a second tab which is really important and this table deals with test animal dosing regime. So first precise the treatment type. So here it was an oral administration. The treatment level, which was 10 milligram per kilogram of dry matter of diet. You have also to precise the vehicle. So here it was gelatin capsule. The parameters, it was test material in vehicle administered to the laying ends. So dosage rate was approximately and measured at 1.07 milligram per kilogram of body weight per day. The timing of the administration was once daily for 14 days, and the timing from final dose to sacrifice of laying hens was around 12 hours. In the sampling table, you can also precise some information about sample collection, about samples collected, sorry. So for example, in this study, the eggs were collected twice daily. The number of eggs produced during normal production was around 0.8 egg per day. The excreta were collected once daily. You have also to precise the interval from last dose to sacrifice, already detailed in the last table. And do not forget to precise the tissues harvested and analyzed in the study, which were abdominal fat, muscle, skin with fat, and liver in the case of our study. In the last three fields of, in the last three boxes of the study design part, you can add a flowchart of the extraction and fractionation scheme. You can also precise some information in the free field text for extraction and analysis, and also you can copy paste or type information in the identification and characterization boxes. So that's all for the general information and materials and method section of the Livestock Mss Composer. And I would like to go back to my presentation to go on with the other section. So after this live session, so I will develop the theory for results and discussion section. As a general, 5 subtabs are present: total radioactive residues, or TRR, extraction and characterization of residues, storage stability, identity of residues in poultry, and proposed metabolic pathway. The last section, proposed metabolic pathway, is generated automatically, so just fill in information for the first 4 parts. Before going through the detail of each part, it must be noted that when you right-click on a line, different functions are available. You can delete row, clear row, insert row, copy row, and clear table. Right-clicking on a column titles allows you to rename it, and these two functions are available for all parts of results and discussions. In the total radioactive residue section, fill in first table about extraction efficiency if data is available. Then in quantitation box, you can precise methods for determining TRR values. Then insert TRR values for various matrices in following table, which represents radioactivity in eggs, tissues, or excreta. To end completing TRR part, report respective results for radioactivity in eggs in function of time in this table. In the sentence TRR in eggs/milk appear to have reached a plateau, select did or did not or left empty depending to results displayed in following table. But be careful, because once did or did not has been selected, there is no way to come back to an empty field for the moment. You can also add an image attachment if needed, and then you have also to describe the general health of the animals during the study in the corresponding field. This last field is a free text field. Let's move to part B, extraction, characterization, and distribution of residues. Several sheets in this section may be available depending on the number of radio labels detailed in part 1 general info sections. These sheets are automatically created. In this example, for example, there are 2 labels and so 2 sheets. You may find first a free text field for description of results, so footnotes, abbreviation. You can detail all of this in this free text. And the table on these slides summarizes extraction and characterization and distribution of radioactivity among the different matrices. So fill in this table with study report results. Nonetheless, several warnings are identified in this section. Pay attention to the number of columns required to report all the data available in the study. 1 column per matrix. Knowing that each subtab contains a 7-column table, if you need 8 columns, you have to create a second radiolabel test item to get the extra columns you need. Do not forget that you can also rename columns, but do not delete column headings because empty headings cause irreversible merger of columns. And do not forget also that the more than sign is authorized, but not the less than sign. Using the less than sign makes information disappear into the Metapath database. In part C of results and discussion, which deals with storage stability of residues, describe the storage condition and discuss if residues are stable during storage. A tab summarizes storage stability data in the study and interval of demonstrated storage stability data. Complete this table for all matrices tested in the study. In part D of results and discussion, which deals with identity of residues, a table summarizes results of identification for compounds in the different treatment group. Several warnings are also identified about this section. So the first one is the same as the one detailed for extraction. So pay attention to the number of columns required to report all data available in the study, because 1 column is relative 1 column per matrix. And knowing that each subtab contains a 7-column table, if you need 8 columns, you have to create a second radiolabel test item. You can also rename columns, but do not delete column headings. These empty headings cause irreversible merger of columns. The more than sign is also authorized, but not the less than sign. And when filling header columns, always start with the parent compound and carry on with identified metabolites, because this makes easier the report of the results of the study report. To end with results and discussion section, I will talk about part E, proposed metabolic pathway. When you click on the Build Metabolic Map button in the upper part of the window of the Mss Composer, the metabolic map is built in part E. But be careful, because the metabolic map can be built only once Appendix 2 has been filled in. I will detail Appendix 2 later in this presentation. The table about identified compounds is also automatically generated and filled in from Appendix 2 data, and a free text field allows you to describe the metabolic pathway and the main reaction, for example, oxidation, hydrolysis, of the analyzed compound of the study. The last section to be detailed in this presentation is conclusion and appendices of livestock Mss Composer. In conclusion, you can briefly present the conclusion of the metabolism study. You can also add the reference of this study. As for plant, and you will see that it's the same for rotational crops, 3 appendices are detailed in livestock Mss Composer. Appendix 1 is a summary of all treatment groups tested in the metabolism study. Appendix 2 is a summary of all identified and or detected compounds in metabolism study. Relationships between active substance and its metabolites are also detailed in this appendix. In Appendix 1 and 2, icons allow you to add a treatment group or a compound, to insert a treatment group or a compound, to delete a treatment group or a compound, and to modify a treatment group or a compound. So these icons and these tools can be really useful. Appendix 3 summarizes information about Appendix 1 and 2 and is generated automatically. This table represents compounds repartition in the different tested treatment group of the metabolism study. You have to know that Appendix 3 can be modified directly, as it's an alternative to the treatment group section of the Appendix 2 editor for establishing the correspondence between treatment group and metabolites. In Appendix 1, the various treatment groups tested in the study are defined and listed as a test. To add a treatment group, click on the plus icon and the Appendix 1 editor will open. A treatment group may be defined by different parameters we will develop. First of all, precise test cell in which treatment group should be named briefly but unambiguously so that they can be easily distinguished. To name it, use the first letters of the labeling, then animal species, then tissues analyzed, and if necessary, dose applied. Information must be separated from the next with an underscore. After this, you have to select male, female, or not reported for gender. You have also to precise the number of animals dosed with a given radiolabel test material. Please specify detailed route of administration. And in dose nominal and dose measured, add the value for theoretical and experimental dose administered to animals. Please precise analyze tissues in matrix and duration of the study in the test duration. Be careful, because fields tagged with a red asterisk in this slide must be filled in to allow import of the MSS XML files into Metapath database. To go on with Appendix 1 editor, you can complete other parameters such as dose type. You have to select single or multiple and clarify if available, if the dose has been done on every or for a certain duration. In the remarks field, you can explain terms and abbreviation. It's a free text field. Before validating the created treatment group, you have to select the good citation, the good radio label test material, the good animal information, the good dietary regime, the good dosing regime, and the good sampling information. These last fields are automatically populated with data previously detailed in the Mss Composer, so you just have to select the good data for these fields. As previously, fields tagged with a red asterisk must be filled in to allow import of the MSS XML file into Metapath database. And you have to click on Submit to validate created matrix and going on adding new tests via the same process until completed. Regarding Appendix 2, Appendix 2 summarizes compounds identified and or detected in the tested treatment groups. Moreover, relationships between compounds are detailed. So you have to click on the plus icon to add parent or metabolite structure. Starting with the parent chemical is the best way to progress logically through daughters compounds, granddaughters compounds, and great-granddaughters compounds when building the metabolic tree. After clicking on the plus icon, an Appendix 2 editor window pops up with several boxes to fill in. First, you have to precise common name and company experimental name if available. For chemical name, enter once again common name, but do not write the full chemical name of the molecules. In the parents box, describe the relationship between the compounds by ticking the boxes that correspond to compounds from which the metabolite can be generated. Relationships are specified for all metabolites except parent compounds. The metabolic pathway is built on the information encoded in this field, so it's really important to be focused on Appendix 2. For treatment group box, tick the boxes that correspond to matrices in which the compounds has been identified. The last section of the editor allows the user to supply some expertise in coding when some difficulties in identification or drawing encountered. You can select none if no issue drawing compounds encountered. You can select expertly specified and assumed by authors for compounds that were not identified in the study, but are assumed intermediate between identified metabolites. And in case of uncertainties while drawing a compound, for example, I don't know, a position of a chemical group which is not clearly determined in the study report, you can select expertly specified and specify in the decision field which assumptions were made when drawing the compound, for example, unknown site of conjugation. Do not forget to click on Submit to validate created compounds. But let's do a short focus on the chemical structure box of the Appendix 2D editor. Click on this icon to bring up the 2D editors and follows direction from previous section to draw compounds. As a short reminder, you can draw a structure by copying, pasting a smile code, and you can also directly draw a structure by using the drawing package. Then do not forget to hit OK to accept the structure drawn. Regarding Appendix 3 to end with this presentation, Appendix 3 is a summary of the distribution of identified compounds in the different treatment groups analyzed in the study. In this appendix, you can see the correspondence between treatment group and metabolites. This table is filled in automatically using the information available in Appendix 1 and 2. And you can link and unlink matrices and compounds by right-clicking in a cells. This can also be done by scrolling, but it's very, very sensitive. That's why we strongly recommend you updating this table using treatment group fields of Appendix 2 in order to not make some mistakes in the distribution of compounds in the different matrices of the metabolism study. Well, I would like now to do a live session about results, discussion, and appendices. So I will go back on the Mss Composer we completed previously. So I will go on part 3, results and discussion first. You can see that there are some different parts, one for radioactivity, total radioactivity, one for extraction, one for storage stability of residues, one for identity, and the last one, proposed metabolic pathway. I think I would like to focus on what is really specific to livestock Mss Composer. So in section ATRR, you have a table which is specific to radioactivity in eggs, tissues, or excreta, because we are working on an N metabolism study. So just fill the results of the radioactivity in this table. Do not forget also to precise the radioactivity in eggs as function of time. When in this table, you can precise the results for this information. In extraction and characterization and distribution, it is exactly the same table as the one detailed for plant Mss Composer. So I won't do a focus on this. Maybe I would like for identity just specify the results of radioactivity for each compound identified in the study in the different matrices. So for this N metabolism study, we have results for excreta, egg white, egg yolk, liver. And to end with results and discussion, we have the proposed metabolic pathway section. You have to click on the Build Metabolic Map in the upper part of the window to make the metabolic map appear. So we have the map here. And there's a table with the different compounds identified in the study with the SMILES code. And there's also a free text box where you can introduce some information about the way the active substance is metabolized in poultry in this example. So in conclusion, just insert the conclusion, and I would like to do a short focus about appendices, because it's really important to detail the right information in these different appendices. Just as a reminder, Appendix 1 summarizes all treatment group or matrices tested in the metabolism study. So if we have a look to this first table, we can see that the first line is dealing to excreta for the cyano-radiolabeled compound. But if we go on the other lines, we can see that others deals with eggs or liver. And if I click on this line, you can see that it's information about excreta, but for the pyrazole radiolabeled compounds. So do not forget to respect the filling instruction for all the other box, so number of animals per dose group, the dose administered, the dose time, the test duration, etc., etc. For the Appendix 2, well, do not forget to precise the right structure of each compound. You can add a compound or you can modify a compound if you want. You can directly paste a SMILE code here to enter the structure of the active substance or the metabolites. Do not forget in the parents boxes to tick the relationships between the different compounds, and also precise where these compounds has been identified in the treatment groups. For example, this compound has been identified in egg white, egg yolk, in the cyano-radiolabeled compounds. Appendix 3, you can see that it has been already generated. I recommend you not to modify this Appendix 3 once generated because it's really sensitive, but for your information, you can link and unlink compound in matrices in the different treatment group. So that's all for this live session. If you want, we have 5 minutes to answer to your question. So do not hesitate. Thanks a lot.
Yes, Vincent, we had many questions during your presentation and we have a few times to answer, but we will try to present the question in a Word document and maybe answer a few of them. If
Yes, I will share my screen with all the attendees. So
we have, I think, some questions regarding the expression of the dose of feeding in, but I don't know if they. I remember that this question were
yes,
asked at the beginning.
there are this question: if percentage dose is mandatory, please specify cumulative daily dose recovered percentage or total dose recovered percentage. Vincent, do you have the answer of this question, or William maybe?
For my part, I have no answer for this question. I'm sorry.
I think maybe I can try to answer. I think it's really depending of the study report and of the results which are detailed in the metabolism study. If the results deals with cumulative daily dose recovered, so just specify it. But if it's total dose recovered, you can also specify it. Do not forget that you can modify title of columns in the table of results. So you can add the information you run depending on the metabolism study.
And I assume that for the second question on how to express the dose and the fact that the milligram per kilo of body weight per day is now required within the new data requirement, I think the same. It will depend on the available data reported in the study report. Can you confirm that, Vincent?
Yes, sorry. Yes, exactly. It's really depending of the study report. If you have the dose expressed as milligram per kilogram of body weight per day, just specify it in the Mss Composer. But if you have not this information, just specify the unit you have for this results from the metabolism study. The most important is that the unit is specified for each value entered in the Mss Composer.
There is a question related to the radio labeling.
Okay.
I think it could be useful, Vincent,
Yes.
if you show how to radio label a molecule.
Okay.
I can't find the question now, but it's in the beginning of your presentation. We presented it on Monday, but we can repeat the demonstration.
I can maybe share my screen with MS, or just do it if you want.
No, please.
No? Okay, thank you. So
I
the Mss Composer.
Yes.
So okay,
Just
here.
a minute. Yes, it's okay now.
We are so on the MSS Composer. So it's on the materials and method in part A, materials, where you can find the radiolabel test material. So to enter the compound, the radiolabeling compound, just click on the pen icon here. So for example, this has been already pre-filled. You can directly paste the smile code of the radiolabeling compound, but if you have only, for example, the active substance, you can paste, yes, the smile code of the active substance. And just here, you can see that there's this information in parentheses LBL14, which deals for the radio labeling of the active substance. And adding this in the smile codes allow you to draw the radio labeling where we can see this on the structure.
There is another way, is to open the periodic table. Maybe
So,
Vincent, you can.
Yes, I do the demonstration, but go on, Gail. I will just click. No, go on.
Select the carbon for 14 carbon. Then, no, yes, you have to tick the label box here.
Yes, here.
Right.
And precise the number.
Yes. Most of the time it's 14.
Yes.
Click on yes. And then add the radio label where you on the atom that you want to radio label. For example, the phenyl ring.
I just put a radio label here.
All around the carbon, on all the carbon, all around the ring.
Exactly, because it's a ring, that's true.
So I hope it's clear, more clear now related to this question.
Maybe I can stop sharing my screen.
Yes, we had also many questions on the possibility to update the software because it seems that the 7-column limit will be frustrating, but for now we did not ask us this question since it's not it wasn't in the context of submitting assessment report, but we can we may be able to show maybe in the next presentation how the render is for these 7-column tables when multiplied, but it's just a matter of format. You know, when imported in the Metapath database, if you have I can say 15-column tables, it will be hard to identify or to check the results. You have to navigate into the documents, and in Metapath it's not so easy to navigate in the tables, so they are presented as a block that could be readable. So 7-column table, and there you have the second 7-column table, and you can see that the data are easily recognizable, and maybe it won't be a real big issue to have only 7-column table, but maybe it can be fixed in a further version of the Mss Composer. Also, I remember maybe...
So I will share my screen again. So maybe, William, you can explain your answer regarding this question, how to import poultry and lactating ruminant into Metapath.
Yes.
Because apparently for some attendees, it's just import poultry.
I can maybe try, but maybe
you already answered, I know,
yeah.
But please share your answer with all the attendees.
Yes. You have indeed the possibility when using the MSS Livestock Composer. You can see many tabs for each species, ruminant, poultry, and pigs. but you have to know that only one study metabolism study has to be informed in one XML file. You cannot inform two livestock studies in the same XML files. Then when you import the XML in the Metapath database, you will only see the first species you informed. So you have to perform one XML for the poultry and one separate XML for the livestock, for the ruminant, sorry. And then you will be able to have the two XML files identifiable in your Metapath database. For now, it's a little bit complicated. Maybe it can also be updated or fixed in further version, but it's how it's working for now.
Thanks a lot for this and for your questions. I think we can have maybe 10-minute breaks approximately, and I will leave the floor to William, who will detail you the rotational crop MSS Composer in the next presentation.
Welcome back, everyone. And I hope the coffee break was a good break. In this last session of this webinar, we're going to see the functioning of the MSS crop composer, so the last composer, which is used to inform metabolism studies in rotational crop. For a remember, metabolism in rotational crop study is a study where the metabolism of an applied active substance is investigated in the crops that could be grown in rotation to the crop which has been treated. So difference duration between the application and the plantation of the following crops are generally tested from 30 days to a year. To give an echo to Vincent's presentation on livestock, this PowerPoint will give you an overview of this MSS crop composer and highlights the specificities of this software compared to what we saw on Monday with the MSS plant composer. So to begin, once the software is installed, just double-click on the icon to open the MSS crop composer. The startup window will appear as follows. You find basically here the same structure for this composer with the basic function, save, render, open, you have in the MSS plant composer. And you also recognize the 6 different sections to inform, from general information to the attachment file. But you can already see that there are multiple crops in different tabs at the up of the page. Here, wheat, lettuce, beet. So as you can see, we have a tab for wheat, cereal grain, lettuce, leafy vegetable, and beet, root crop. Because generally, the rotational crop are tested to cover the different group and anticipate the various crop that should be or could be planted as a following crop. So a really important thing to know with this MSS crop composer is that you have to inform different data for the different crops, but you only have to inform the general information, material and methods, and all the study parameters only for the first crop tested. Indeed, these parameters are common to the whole study. So when you will move to the other crop tab, you will see there is no need to replicate this information, and you only have the 2 tabs to fill for this following crops, so lettuce and beet. The tabs are the results and discussion tabs and appendixes, as you can see on the screen. So let's take a view of the first tab, general information. So here, be careful, you only have to inform this for the wheat crop. But the manner to inform the data is globally the same that we saw on Monday on the MSS Plant Composer. So one citation is for one study report. If you have several reports, you can add citations to enter the parameters. Then proceed by filling all the relevant fields when information is available. Describe you can add the identifier. Sorry, you also have to describe the guidelines. And down the page, you have to describe the product type as it's presented in the MSS Plant Composer and the product use. So put this information, and it's the same manner to fill general information than in the MSS Plant Composer. Here, since you know you have, if we move to the Material and Method tab, we will find two sub-tabs, so Material and Study Design. On the Material tab, which is on the screen, it is also globally the same manner to fill the information that has been seen on Monday. In this box, you can manage the radiolabeling and create the new radiolabel if needed. And when the radiolabel is created, inform the data and radioactivity of the tested compound. You can inform the physicochemical properties data in this table, but pay attention to this table too. The tested crop are presented here, and the name you give to the tested crop in this column is the one which is reported in the top of the page for each rotational crop tab. So as you can see, the same name. In this table, you can only inform the 4 row maximum to present 4 rotational crops and soil if necessary. For the other parameters and the soil type and environmental condition, it is the same way to fill than the MSS Plant Composer. In the second subtab, Study Design, you will find the field to describe the experimental condition, but also the use pattern information, where application rates, plant back interval, and also timing of application are to inform. So the plant back interval is the duration between the application and the plantation of the following crops. It is always globally the same manner to fill than the MSS Plant Composer described on Monday. So below these 2 fields, you can also find the field to attach some extraction schemes when relevant to you. I want to answer maybe question. I do not know how to attach more than 3 schemes to this part. Maybe my colleagues can answer after this, but we do not answer to this question, which was asked in the previous presentation. And you have the way to attach the flowcharts. You have also a free field to describe the extraction and analysis method, and also the field to describe identification and characterization parts. Let's see now the results and discussion tab, which is the following tab. So in this result and discussion, you remember that you have to remember that for the previous tabs, so general information and study design, you have only to inform the data for the first crop tested. But here for result and discussion, all the tested crop data have to be informed. So you have the wheat here we are in the wheat, but we also have to put the results for lettuce and beet and soil if necessary. So in this tab, you will find the 5 subtabs we have already seen: the total radioactive residue, the extraction tab, the storage stability tab, and the identification tab. But let's focus on the first tab. Sorry, I put this warning that remember to inform result for lettuce and beet and soil to result and discussion. So if I focus on the first tab, total radioactive residue, globally it is the same way to inform data that in the MSS plant composer. Just begin with the extraction efficiency data if available in this field, and then fill the free field to explain results of quantitation in the different matrices. And to finish, you have to fill the TRR in matrix table, which regroups the TRR and quantified values in the various matrices. In the row, you will inform the different parts of the crop analyzed, and in the second column of the you can see that we have informed the different plant back interval corresponding to the good radiolabel. Inform the TRR value for each row and each analyzed part of the tested crop. When all the information has been informed for a crop, you will have to repeat this operation for the other tested crop. So you will have to go on this tab just by clicking on the crop you want to inform the results. So let's see then the second subtab for extraction and distribution data. So in this tab, it's always globally the same manner to populate the field and the tables that what has been done on Monday. So here you have a pre-filled separate tab for each radiolabel. Here we have 4 radiolabel which has been created. So we have the first cyano and pyrazole carbonyl radiolabel, but since for the wheat we have more analyzed matrices than 7, which is a limited number of columns, we had to create a second radiolabel, a duplicate of this one, to inform the result for other matrices. As you can see, we have results for grain with 2 plant back intervals, so 2 results, 2 columns, 3 plant back interval for forage, so 5 columns, and then with hay and straw we reach the 11 columns, sorry, and you have to create a second radiolabel to inform these results. It was to remember use the specificity of this table, which can contain the maximum of 7 columns. In the free field, you can inform as well the additional explanation on the result table, so the footnotes, abbreviations, and you can manage the table as you want to populate the results. So you can add or delete rows, you can modify columns headings, but always be careful with deleting the column headings. And after this, you have to inform the distribution of the TRR in the different matrices and with the different extraction method. Remember that more than sign are authorized, sorry, but not the less than sign, which makes the information disappear where imported in the Metapath database. So if we move to the third subtab of this result and discussion part, storage stability of residue, you will find the free field to describe the storage condition and discuss on its potential validity. You will also find the table to report data, which demonstrates the storage stability with duration, temperature. It is the same manner to inform this tab than in the MSS plant composer. Then we are going to have a look to the de-identification of residue in rotational crop sub-tab. As for the MSS plant composer, the section summarizes the identified compounds, metabolites or potential conjugates, and their individual TRR values. There is as much radiolabel groups than in the table B we just saw before, and you can add information in the free field as well. You also can add and delete rows, but try to ordinate the different commodities and inform the respective residue level and TRR in the table. Some warning before going ahead, so I repeat this information, even if it's frustrating, we may have only 7 columns in this table. You can rename columns, but do not delete column headings. The more than sign is authorized, but not the less than sign in this kind of table. Also, when filling this header column, always start with the parent compound and carry on with identified metabolites. Then, let's go to the last section of Result and Discussion tab, which is the proposed metabolic pathway. So in this section, you can, as in the other MSS Composer, build the metabolic pathway, but it can be built only once Appendix 2 is fulfilled. So you may as well describe the metabolic pathway in the free field, but rather wait the full completion to do this. Remember that for all this section in the Result and Discussion tab, you have to populate data for each tested crop. So when data are filled for the wheat, repeat the process for lettuce and for beetroots. If we go ahead through this MSS Crop Composer, the next tab is for conclusion. This tab should rather be completed once all data are informed, but basically you can find one free field to conclude as you want on the study and report a summary of results. And a second field is present to inform references of other metabolism studies referred to, and you also can include some study parameters. It's not the most important tab of the composer, but let's move to the last tab, which is important. The fifth tab is for Appendix, so you begin to know this tab. So in the Appendix 1, you may summarize all the tested matrices for each tested crop. Each matrices may be defined by some parameters. Application rates, number of application, plant back interval, matrix sampled, etc. Be careful to the nomenclature filling this data, but more details will come in the next slide. In the second appendix, all the different compounds identified in the metabolism study have to be informed. For the sake of clarity, please begin with the parent compound and carry on with identified metabolites. After completing all the compounds, this appendix will allow to insert relations between all these metabolites and their parent compounds. The last appendix will summarize the relation of one metabolite with one treatment group in order to identify finally in which matrix the compound should be found. But let's make a focus on the way to inform data for the first appendix, as it has been presented in the previous MSS Livestock Composer presentation. For the first appendix, you can fill this with Appendix 1 editor, clicking on the zoom icon to open the editor. Remember that all the fields with an asterisk must be filled to allow the importation to the database. And please pay attention to the nomenclature when informing these fields. I will then focus on this field. So you have the test material. So the test is the treatment group. You have to name the matrix briefly but unambiguously so that they can be easily distinguished. We proceed by the first letter of the radiolabeling, the portion analyzed, and the dose applied, and PHI eventually. Every information has to be separated from the next with the underscore. The second mandatory field is the plan back interval. You have to inform the value, but separate it from the unit by a space. You also have to inform the application rate used on this treatment group. You also have to inform the unit, so to separate the unit by a space. The number of application is also a mandatory field to inform. The matrix is also mandatory, and you have to enter the matrix on which has been sampled. Sorry. And citation, as you can see, is also important to detail. So you just have to select the corresponding citation as informed in the material method part. Sorry, general information. The radio test label material should be selected in the list. Also for the tested crop and the soil type. When all the mandatory fields are informed, just click on Submit to validate the created matrix. I would like to emphasize that Appendix are really important to coordinate data and how it will be available when imported in the Metapath database. If we take a look at Appendix 2, it also can be informed with the Appendix 2 editor. So when clicking on the zoom, you will let this box, Appendix 2 editor appear, where you can describe metabolites name and relation with their parents, and the parents are other metabolites. You now have in this matrix to inform when a compound has been identified in a specific treatment group and when it is related to another compound. When you finish to do this, following all these advices, just click on the Submit button to validate the entry. I would like to show you a little remember of the structure editor, which is available also in this Appendix 2 editor. By clicking on the pencil icon, you can let appear this 2D editor when you will be able to draw and create the different metabolites identified in the study. When you have created the molecule, click on Validate to finish. Moving on the third and last appendix, it can be seen that the table is automatically filled with information entered in Appendix 1 and 2. So this appendix is summarizing the relation between a metabolite and a treatment group. You can modify this table, but it is really sensitive and you should be careful by modifying it. To conclude, I want to go on a live filling session to show you how this MSS crop composer has some specificity compared to the MSS plant, and to insist on these specificities. So I will show you the presentation of this MSS crop composer. So as you can see, you have your different tabs for the different tested crops. I will show you how to modify this header title, and I will show you too that when moving into this other tab, you have only results and discussion tabs to inform. So to this one, general information. So you may add general information, but it's not the part I want to insist on. I would like to show you maybe this material and method tab, which is really important since it's here we can see that the tested scrub have to be informed. So just to modify this field, I wanted to show you that there is a limited number of fields to this one. If I want to create another field, it will be inform me that this table has fixed dimension. So some of the table are giving this information. If you don't want to use the end user guide to fill the composer, some information on the limited field are available in the MSS, but I don't know if it's available for all the table or all the fields. Here, I have also tested in my rotational crop study the soil. So I can enter the soil and I can see that it is the same thing I enter in this field, which is reported here. So it was a webinar soil. Here you can inform the data on what and when has been sampled the commodity. So it's beet seeds have been sown. It's a sown period, and the harvested period is here. So as you can see, there is a little inversion. I think foliage and roots were sampled for beet and beetroot commodity, and the whole lettuce was sampled for the lettuce. Also for the soil crop, we sampled the soil. And here I have my different tested crop in my rotational crop study informed in order to complete the results. If I add another crop, I just can change the name into this part. So to modify this header column, it is a material and method material to test crops, crop information. It is in this part you can modify this header column. If I go to the study design, you can see that it's barely the same information presented that in the MSS Plant Composer, except that here we have the plant back interval to inform instead of the PHI. So another field important to see is the resultant discussion part. So I wanted to show you that for my pyrazole carbonyl, I only have fields to present grain and forage results. But as you can see, for my cyanoradiolabel, I have these fields, but I had duplicated my radiolabel to inform the other data on hay and straw for wheat. To do so, I may create a duplicate of the radiolabel. So go back to the material and method materials tab, and then add a new radiolabel. Since it's the same than this one, we can just copy paste the radiolabel and put this information here, and we will add this little for identification. As it's the same radiolabel, it's the same radioactivity parameters, so I just have to copy paste these parameters in it. Also, I see that my radiolabel is empty. I can go to the radiolabel I want to duplicate. I click on the show 2D options. I can copy my smile code here, so it's copied. And in this label, I go on the 2D editor and paste my smile code in order to get my molecule down. I click to OK, and my second duplicate is created. When I go back to my result discussion part, I can see this pyrazole carbonyl second tab has been duplicate tab has been created, and I have to inform my results here. Since it's results for the second part of the sample of wheat, so A and straw, I will have to rename the column by copying the same field what are informed here. So I will have matrix 1. So to modify a header column, just click on the right button on the column and modify as you want. Remember to well ordinate your column's heading in order to make the table really easy to read. So I have hay at 30 day after treatment. I think it's plant back interval, but after treatment, and also hay at day after treatment. I also have my straw sample. And at a year of interval. When I have informed my header columns, I have to copy the identified metabolites in this part. So I am directly gone on this identity of residue in rotational crop, but since you created the new tab here in the characterization table where results are also to inform, you can see that this table is also empty, so you have to manage results in both tables. Here I can go with my parents, so it's the same compound that identified here. So I just have to copy paste the metabolites tested in the study report and put them just below your parents. So always proceed with the parents and all the identified metabolites. So I can do this for the 3 first metabolites, but you see I can add rows to inform all the identified metabolites in the study. After this, I go back to my study report to inform the good TRR values. So if I go to the study report, I can see here only 52.2% of the TRR has been identified as the parent. The first metabolite represents 1.5%, corresponding to 0.5 milligram per kilogram, and do this for all the identified metabolites. I don't want to fill all the table. It will be a little bit long, but remember that it is for wheat, but we also add in the rotational crop lettuce and beetroot. So when I finish to do this for wheat, I have to inform these results to these other crops. If I move then on the appendix, which is the last important tab to generate, I can go there. Sorry. So for appendix, remember that you have to inform the treatment group following a nomenclature in order to be used in the Metapath database. You can modify these parameters, or you can create new rows by clicking on the plus icon or clicking on the zoom icon when want to modify a treatment group. So I informed the test, the plant back interval application rate, the matrix, and the number of application. And I have selected my citation, my radiolabel, and my tested crop and soil type. All this information are mandatory and are sufficient to report my group into the Metapath database. When all my treatment groups are informed, so you can see that I have for my cyano radiolabel the grain at 2 plant back interval, and for my pyrazocarbonyl radiolabel the same grain at 2 plant back interval, but also forage, and under we will have, but I do not modify according to the good nomenclature these fields, forage, hay and straw results. Here in the Appendix 2, you have all the identified metabolites with their SMILE codes and all the related parents and compounds. So if I click on this, I can edit this row, and I can see is related with the 12 metabolites, and it has been found in forage at 30-day plant back interval and in A also. So the box has been ticked, and no error on the metabolic structure has been identified, so everything is okay. I click to submit, and all the relations are appearing here. Let's then go to the last appendix, which are summarizing the relation between all the metabolites and the different treatment group. You can see that we have different metabolites here, and you can see that it's really sensitive. Since I just scroll with my mouse, and the linking is appearing or disappearing. So be careful using this matrix, using this table, sorry. So I just gave you an overview of some specificities of this MSS crop composer, and I wanted to show you a little recap of what we saw with a little video. To summarize, here are the key points. Rotational crops Mss Composer equal the plant MSS with some specificities. There are more tabs to fill since there are multiple crops tested in metabolism in rotational crop studies. The wheat, the carrot, the lettuce, the beetroot. Be careful. General information are to fill for the first crop only. The other tabs for other rotational crops presents only results and appendixes. Remember to save your file regularly if you don't want to lose your work. This does not work. This is. Present an ambiguous and relevant result table respecting nomenclature and advices. If you don't want to pull your hair, try to ordinate your table with column and rows like this. Remember that Appendix 2 is to inform before building the metabolic map. If not, it is unable to build the tree. Thank you for your attention. So thank you for your attention. I think we may go through a little Q&A session on this part on all the MSS Composer. So feel free to ask questions, and I will join my colleague to answer it.
Maybe Vincent, you can choose some question and some answer that you already give.
Yes, I can do this. I try to answer to most of the questions. we have a question, for example, when importing a rotational crop, only the first crop gets imported. What am I doing wrong? Does the same apply as for the livestock and plant composer, and you can only fill one tab at a time? So for this question, when importing a rotational crop XML, all crop sheet will be imported in the Metapath database if appendices 1 and 2 have been filled in for the rotational crop. So all the crop with appendices filled in will be imported.
Sorry, Vincent.
Yes.
Since I had this question using the Metapath software, maybe I should just show a little bit when imported in the Metapath what the rotational crop will give.
Good idea. Thanks.
I just project so my Metapath screen. So on my screen, you can see it's the Metapath main screen, and I will just import a rotational crop study just to show you that its specificity. I import an MSS XML file. I have a rotational crop prepared here. And when I have imported this file, I can see that three different cards are available here. So if you go to the first one, it's only the wheat, but also you have lettuce here. So as you can see, oh, it's not the good nomenclature, so you cannot see this, but it's lettuce and beetroot. So don't worry, and the one MSS crop composer XML is splitted into 3 metabolic pathways, one for each crop in the Metapath database. So it's just a precision I wanted to bring. You can see the 3, so it's for beetroot, for lettuce, and for wheat. Compared to one XML file on plant, which is giving only one card in the Metapath. Sorry to interrupt. Maybe we can go back to the question.
No, thank you, William, for this demonstration. I think it illustrates very well how the data can be viewed in Metapath and how the data are reported in the database. So yes, I will share my screen again. I think this question and the answer that you give is interesting to share with all the attendees.
Yes, so the question was, how do you deal with oilseed crops grown in rotation? Because that's true that in the example that William gave us, there was, I think, cereals, sugar beet also, and lettuce. Sorry. And so what can we do with oilseed? Is it possible to add a tab in materials and methods? And if oilseed crops are detailed in a rotational crop metabolism study, it's not a problem. You have just to precise the rotational crops tested in the metabolism study in the table B791, which deals with crop information. This table is in part A, materials and method of the MSS Composer, and the oilseeds crop sheet will appear automatically. So no problem with oilseeds crops for rotational crop. I think we have also some question about mandatory fields. Few questions about this. Yes, obligatory fields are also specified in the manual. Yes, indeed, in the manual, the mandatory fields were specified, but these fields were considered mandatory in the framework with BFR in filling in the MSS Composer for existing metabolism studies. So it was just to do a reminder about these mandatory fields. Yes, go on, Gaëlle, sorry.
No, it's okay. Please continue. I think there is a question related to the saving on the last question in the chat. just saw in the video that some methods used to normally save files would not work. Can you clarify how to save, please? Maybe, William, if you want to share your screen and explain how to save the work and explain the issue that we encounter with this.
Yeah, so if I project my screen, well, you can see that I have my information here. Usually, when you're working on a document, you take shortcuts to save your file or to copy paste or to something. So the shortcuts are functioning for copy pasting, but to save, the Ctrl+S for Control Save for PC at least is not working here. So you have to just click on the icon, click on this big icon, save or save as. I save this file. The issue is sometimes you are filling 2 XML files in the same day, and you want to switch to another file. And when you switch and open the other XML file in your sorry, it's not a rotational crop study, so it cannot be open with this. But when you switch from a XML file to another, you will want it just to know how you reported the information in Material method for the other map, and you go there and you didn't save, and when you come back to your card you was editing, all the work is lost. So just click on this icon regularly, like when you enter a field or when you enter a tab, you save. When I enter this tab, I save. When I enter this first table, I save my results. Then I will not be frustrated by losing my work and working hard on this Mss Composer that are already long to fill. So be careful.
So I know that there are other questions in the chat, and for the technical question, we will answer after the webinar. But so don't hesitate to ask us new question in the chat. We will have a look on them after the webinar. But if you agree, William and Vincent, I think it's the time to conclude and to share a few last information regarding Metapath and the Composer.
Of course.
So we'd like to thank you, all the attendees, for coming to this webinar, and we hope that it answers to all of your questions on how to complete Mss Composers for pesticide metabolism studies. As a conclusion for these 2 days, we'd like to share with you how to use the Mss Composer, and especially and how to use Metapath. And yes, and especially how to view the metabolic profile in Metapath, as William already show you, and how to make a research with Metapath. So for that, we will watch 2 short movies prepared by our team and already available on the EFSA website. So the first chapter is on how to opening the Metapath application and how to load the database, an existing database, and then we will I will show you a video on the different information completed in the MSS could appear in the database, and then how to perform a searching.
Chapter 1. Opening the application Metapath and loading a database.
First of all, make sure the application Metapath and the database are saved on your computer desk. For the database, a data file with the extension .mtb is needed. Click on the Metapath application icon to open it. You have now to load the database. Click on File, Open. The window Select Database opens. Select the network location where the database is saved. Click on the database.mtb. Click on Open or on Enter key of the keyboard. A second window appears asking for a username and a password. Select Administrator and type in the password CCR. Hit Login. There is a blue progress bar at the bottom of the screen to indicate data loading progress. It can take several minutes. When the database is loaded, the program opens with the following screen showing the first map in the database.
So again, a short video on how,
Chapter 3. Highlight treatment groups.
Clicking on the button Highlight Treatment Groups brings up a checkbox listing the treatment groups and/or the tested conditions. Select any box under Coloring and Specifics to surround the metabolites with a color-coded box that link the metabolites to the selected treatment. Click on any box under Coloring and Specifics to get the detailed description of multiple parameters of the study shown below, such as the radiolabeled molecule, citations, tested material, the treated plant or animal species, sampling details, application dose and rate, and other additional information. If this is not showing, click on Show Details for it to display.
Chapter 8. Similarity Search and Comparison of Maps. There are two types of similarity searches, whereby all the maps of the database are compared to either a single chemical structure or entire map. During the process, maps are evaluated with a percentage grade as to the similarity. First, click on the Similarity tab under the Search drop menu. A search box comes up for similarity with two tab options, Chemical and Map. The first similarity search is based on the chemical structure. The Chemical tab is chosen. Click on Draw and a structure editor window comes up where either a smile strings may be entered or a structure graphically drawn. Let's draw a chemical structure, for instance, chlorophenyl. When completed, click OK and the editor window closes, leaving a structure and smiles depicted on the search screen. Then, click on Start Similarity Search to activate the search. The second similarity search is the Map Similarity. It is located under the Map tab. You will see that it is empty and a map must be loaded. Click and drag the search query box over to the right to visualize the list of maps in the upper left of the program page. Double-click to select a map. You will see it in the search window. This is the map which will be used as a search query. Then, hit Start Similarity Search. Accept the defaults. Hit OK, and results are displayed in another window. Adjust the window size and appearance for optimum viewing. The selected map with 1,3-dichloropropane will be compared with all other maps in the database. However, only results with similar structure will be shown. The results found common metabolite structures in one other map within the database. Those in green above are common to both. Those in yellow are conjugates, and those red are not common. This feature, Map Similarity Search or Chemical Similarity Search, is ideal for looking for common metabolites across chemicals. there is a map comparison feature that compares two selected maps, ideal for comparing metabolite results across different radiolabel studies. The Compare Maps feature, found under view of the drop-down menu, is like a similarity map search, only you are comparing two designated maps and not maps of the entire database. Click on Compare Maps, and a small box with instruction will come up that instructs you to first choose a map by Ctrl+click, and then Alt+click on a second to activate the comparison. Note, you will have to close the instruction box and then choose your maps for comparison. The results of the comparison will pop up in a window. Map on left is the first chosen map. Upon comparison of the two maps, green are common and red different. Colors of boxes are explained by clicking on Colors legend icon on menu bar.
So we hope that these short movies give you give you a short picture of how to use Metapath and all the possibilities using the Metapath database. So on the next slide, it's just a summary of all the available documents already available on the EFSA website. On this, at this link, there is a link to the there is a link on OASIS website where you can download Metapath, the Mss Composer, and the Dietary Composer for that. A link to the Mss Composer advisory notice, the short link to the videos, and also the EFSA public collection of maps. So as we said at the beginning of this webinar, all the videos and the Q&A will be published on the EFSA website. Vincent, William, and I like to thank Carla, Francesco, and Alberto for their support for this webinar during the organization and during these two sessions. And thanks to all the EFSA team also to give us the opportunity to present the Mss Composer. So now I will give the floor to Benedict.
Thank you very much, Gael. So after all the hard work of the ANSES colleagues over the past days, I think I have a very easy job to do the closure of this webinar. So I think the goal of the webinars was to train you on how the Mss composers need to be compiled for plants and livestock, and how to report the data in this tool. And we're very confident that the past 2 days training, together also with all the material that is available, like the detailed manual that can be found on the website and was displayed by Gael, should provide you the necessary information to start using and compiling the Mss composers. I think as scientists, whether it's from an applicant, regulatory, academia perspective, we're all thrilled probably by the possibilities the world of structured data is opening. But we're also very much aware that this comes with a certain price. That I mean, the way to get to the perfect systems, the perfect tools is not always that straightforward. And as they say, Rome wasn't built in one day. However, the webinar was mainly focusing on Metapath, and I also would like to put it a bit in the context because it was not a Euclid training, and we saw that in the Q&A, as expected, of course, and its logic, there were also quite some questions linked to Euclid, because of course both are closely interlinked, and that's why we also received questions related to Euclid. So I would like to refer all of you to also have a look at the Euclid MRL manual that is now publicly available as also on the EFSA website, and where it is described in detail what should be reported where. EFSA paid a lot of attention to avoid application of information, asking applicants to insert information in different tools again, and so to avoid application between Euclid and the MSS composers as much as possible. However, we cannot avoid a minimum of the application for some administrative fields and some technical fields, at least for the time being. In order to avoid this in the future, EFSA is working with BFR colleagues on the future full integration of Euclid OHT with Metapath. However, we are not fully there yet. So yes, we know that there is some overlap, but yeah, we are working on also a longer term, even better solution. I would also like to highlight the upcoming publication of the workflows, where you also will find replies to some of the questions that were raised regarding the use of Euclid as an e-submission tool, and how the data will be submitted, validated, used, and shared, and also how the Euclid composers will coexist during the next years. This document will be published next week on the EFSA Knowledge Junction, and the respective Metapath page that was developed will be updated to provide a link, so all the information is available in one single place on the EFSA website. So in case we did not manage to answer all your questions, please feel free to resubmit them or to submit them via email. The email address is the pesticide MRL mailbox, so please don't send any questions directly to our ANSES colleagues. I think they already did a very hard job, so please contact us. As also mentioned, and I think it was one of the questions raised, proposals for further improving Metapath can also be submitted using the Euclid Open Backlog, so for which I also provided the link. The recording of the webinars, of today, but also of Monday, will be available very soon on the EFSA website together with all the presentations. And you will also receive an evaluation form to provide some feedback on these webinars, so we can further improve this format for future similar events. So last but certainly not least, I want to have a warm welcome, warm thank you to our ANSES colleagues who did a great job in preparing all this and share their long knowledge and experience, but also their passion, I think, for Metapath and how structured metabolism data could help all of us in the assessments. So thank you for sharing your experience and your knowledge with all of us. And then lastly, I want to thank all of you for your attendance the past days, and I wish you all a happy Easter. Thank you.